Hello.
Okay, so good afternoon. Hope you had a nice lunch. It's very hot outside. Nice to walk. Well, don't know. So let's start. Let's start our fire talk session. So I will call the first one, Abner. Then please follow the names. And after Abner, please, I will not call, just Adam, please come in and so on. Okay? So, Abner? Not here?
Hello, my name is Abner Vinicius. My supervisor is Francisco Cervena, Professor Francisco Cervena. My work is called crack resistance of lithium disilicate glass ceramics. Its objective is analyze the behavior of crack resistance, increase the crystallized fraction of LS2. In the first graph, we can observe the probability of cracking as a function of applied load for different crystallized fractions. In the second graph, we can observe the increasing in the probability of 50% when we were in on the where is measured the crack resistance. Here there is a relationship of between these measured values of CR and the crystallized fraction. When we observe the decrease, except in the values of 5 and the only 100%. Thanks.
Thank you. Yes, please, Abner. So you have a gift from the school. Oh. Yes.
Hello, everyone. My name is Adam Puchalski. I'm a master's student at Warsaw University of Technology. My topic is structure and thermal conductivity of high-pressure treated silica glass, a molecular dynamics study. My supervisor is Professor Tomasz Pietrzak, who is present here, and Professor Paweł Kębliński from Rensselaer Polytechnic Institute in the US. And the objective of my study is to study what happens in glass when we apply ultra-high pressure up to 16 gigapascals on the thermal conductivity, and what happens to the thermal conductivity. And the second objective is to study the structure and see how this structure influences the change in thermal properties. We can see that what happens is when we press the glass and then relax it, a refraction of 5-fold coordinated silicon atoms in the structure increases. And this you can see on the first figure that the density in ambient conditions increases, and so does the fraction of 5-fold C, up to around 0.07. And this is the main mechanism of densification in glass. There is no change in intermolecular distance. And on the second figure, you can see the thermal conductivity. So it's obtained by Green-Kubo method in the simulations. And you can see a small increase with the highest pressures. And this generally follows a model of minimal thermal conductivity. On the last figure, you can see how the 5-fold coordination looks like. On the left, we have the 4-fold coordination typical for silica glass and other glasses with 4 valence. And on the right, you can see the pyramid structure that happens with 5-fold silicon. Okay, thank you.
Just remember, 1 minute.
Good afternoon, professors and fellow students. My name is Amino Adamu Habib, and my research focuses on synthesizing yttrium ion garnet crystals within lead oxide and barium oxide-based glass ceramics. Yttrium ion garnet is a ferrimagnetic material that is very crucial in magneto-optical applications, including Faraday rotators. So I investigated how varying yttrium oxide and iron oxide doping concentration affect the crystallization, microstructure, and optical properties of yttrium ion garnet crystal. When you look at the Raman spectroscopy and XRD, it confirmed the successful nucleation and crystal growth of this material within the glass matrix. Also, the Raman spectroscopy show a varying peak intensity at around 188 and 267. This is due to possible correlation between the crystal environment and composition. Similarly, the optical microscopy show a well-defined yttrium ion garnet cubic crystals within the glass matrix. The last row of the optical microscopy is the crystals that is separated during acid attack. Also show the cubic structure, which is also the purity of this material. So this research opened doors for potential application in magneto-optical devices. It will also interest you to know, to the best of my knowledge, that this research is a novel research. So hopefully me and our research group, we might get a Nobel prize. Thank you for listening.
Precisa de foto, né? Precisa de foto? Todos? Ah, boa.
Hi everyone, my name is Anna. I'm a PhD student in the Department of Materials Engineering at USP, São Carlos, under supervision of Professor Eduardo Bellini. My research focuses on additive manufacturing of glass and glass ceramics. I especially work with vat photopolymerization techniques. In the poster, I will present my results about diopside glass powder suspensions for 3D printing, and the thermal treatment to 3D print the parts to obtain glass ceramics for applications as substrates in electronic devices. For that, we prepare the suspensions and characterize the rheological behavior by measuring viscosity, shear stress, and stability. Based on this result, we choose an optimal condition to proceed with 3D printing process. And after that, the parts are thermally treated for the binding and sinter crystallization, and followed by the evaluation of the shrinkage and the visual inspection at the first moment. So I will be happy to share more details with you on the poster session. Thanks for having me.
Redondo, hein? Ah, você tem o cronômetro.
Uh, Hi everyone, good afternoon. My name is André Tamaki Yoshioka, and I am an undergraduate student at the Federal University of São Carlos, working under the supervision of Professor Zanotto. The title of my work is Development and Evaluation of Ultra-High Refractive Index Glasses via Artificial and Natural Intelligence. My objective is to develop and evaluate ultra-high refractive index glasses with high niobium oxide content. Specifically, I investigate how the impurity levels in the raw material affect the coloration of the glasses. Now, let's take a look at some results. First, I successfully synthesized the glasses, measured their properties, and compared the experimental values with predictions. Then, I changed the niobium oxide grade, which led to a noticeable coloration in the glasses. Thank you.
Good afternoon for everyone. My name is Andres Cárdenas. I am a master's degree. Right now I am studying the effect of high pressure on the crystallization process of this last system. What is the main objective of my project is study this process of crystallization. This material has 70 years of researches, but right now there are no many information about what happened in high pressure, and that is the important for my project. Here there are some the phases that we have when the temperature treatment is different. Right now I am in the process of calibrating the equipment for this process. Thank you.
Hello everyone. My name is Arthur Barbedo. I'm a master's student here in the Physics Institute of São Carlos under advising of Kleber Renato Mendonça. And actually this is not my main project of the master's. I work with nonlinear spectroscopy in perovskites, but this is part of the group experiments we are doing in some glasses, and to do some nonlinear characterization of these glasses. In this case, the influence of bismuth oxides in cold dope phosphate glasses, and particularly, we did some NER spectroscopy that normally they use Z-scan for measure the nonlinear refractive index. So one part important of this work is this technique, and everyone that is interested in this different technique can go in my poster and we can talk a little bit more. So thank you.
Hello everybody, good afternoon. Thank you for the opportunity. My name is Avas Kader. I came from Technical University of Freiburg. This is a mining town, and they have a small university but very good profile in mining and metallurgy. My topic is actually ceramics. I'm a ceramist working in ceramics for 7 years almost. So I'm investigating plasticity in ceramics. So ceramics are not famous or known for plasticity or ductility as metals, because people think that there are no dislocations, but it's not true. There are dislocations, but we have to mobilize them, and we need a high energy. So we can discuss in a poster in detail, of course, that how it can work. So I'm investigating actually the lattice defects. How can we exploit them, what kind of defects and what density or distribution can play a role to make these ceramics, especially super hard ceramics, to make the tough and hard. Those people who are working in crystalline glasses, and if they want to tailor their properties, these defect engineering roles are very important. So we can discuss also during my poster sessions. And also that my future project, probably, I'm not sure yet because I'm finishing this job here. It will be glasses, so especially the melting of glasses by hybrid waves, and also the additive manufacturing. It's not promised yet, so I'm open for a new role and looking for this. So that's why I was recommended to go for this school and find an opportunity and to learn more. So I'm happy here to be here, and I'm also looking forward to learn more and enhance my understanding in glasses. Yeah, so if you come to my poster, so I can show you some evidences of plastic deformation or plasticity. There is plasticity, but little. Thank you.
Good afternoon. My name is Caroline Jesley Magalhães. I am an undergraduate student at the State University of Ponta Grossa. And I am also conducting scientific research under the supervision of Francisco Carlos Serbena. This work aims to investigate the mechanical properties of biosilicate glass ceramics. We got the X-ray diffractograms of the various crystallized fractions, which a crystal size of 50 microns and 45 microns. More details will be provided on the poster of the work shortly. Thanks.
Hello, my name is Caroline, and today I will talk about my work titled Synthesis and Characterization of AG-doped sodium borate glass. The main objective is because we test different concentrations of silver and test different luminescence techniques. And for that, the main application is dosimetry field. We can see here the doped sample under the room light, and we already noticed the difference because of their dose. And under UV light, we can check the creation of a luminescence center at 100 grays with orange emission. This emission was further confirmed by the excitation and the emission spectrum. Because with excitation, the most intense was the UV region, and for the emission, we have, after radiation exposure, the emission orange. So this can suggest a novel RPL material for dosimeter applications. Further details are available in my poster, and I'll be happy to discuss them with you. Thank you very much.
Hey, I'm Eric. Basically, I applied X-ray diffraction and small angle X-ray scattering to study a very weakly scattering system of self-assembled microspheres in a conjugated polymer. Okay, so despite it having a very amorphous XRD pattern, we were able to give it unit cell parameters in an orthorhombic unit cell. And by doing sex analysis, we were able to predict the shape of the scattering centers, and also by doing an inverse Fourier transform of the scattering data, we obtained the size distribution histogram of these scattering centers. And this was, of course, corroborated by electron microscopy.
Hello, everyone. My name is Evaldo Hoffman. I'm a material student. I'm a master degree student at Federal University of São Carlos. I'm working in Lamavis Lab. My advisor is Professor Ana Cândida. First of all, welcome to Brazil. Welcome to Glass School. And about me, I'm finished my graduated in 2023 and started my master's in 2024. And about my research, I'm studying acid structure via glass ceramics, that's composition with sodium. I'm preparing my material with use the flash cinder crystallization. And for the any applications or in value in the batteries, solid state batteries. And maybe you wonder about the questions, why is the sodium instead of lithium? Because the lithium is a very shortage and extremely recycle is difficult and the high pollution product process. And why is sodium state instead of liquid states? Because the solid states in the increased safety in comparison liquid states, obviously, high energy densities and the great thermal stability. And why use the flash cinder crystallization to prepare the material or the phase? And because the flash cinder crystallization, the more very energy efficient compared to the conventional process. And my preliminary results show we can obtain the similar results, the conductive values for the flash cinder crystallization compared to the conventional crystallization. And for more details, I'm inviting anyone for my poster. Thank you.
Hello everyone, I'm Floriane Pellerin. I'm a PhD student at Université Côte d'Azur in France. My supervisors are Mathieu Bellec and Wilfried Blanc, and I work on the femtosecond laser tuning of oxide nanoparticles contained in optical fibers. So here on the left you have the core of a fiber which contains nanoparticles, and what we do is that we focus the femtosecond laser into the core to heat the material and change the characteristics of the nanoparticles, and on the right side you have a modified core. So if you want to know a bit more about the interaction between the laser and the matter, don't hesitate to come and take a look at my poster. Thank you.
Good afternoon. My name is Gabriel Rocha. I am a master student in material science at the Federal University of Rio Grande do Sul. I am work with soda-lime glass, which are composed of silicon, oxide, calcium, and sodium. My goal is to modify the optical properties using ion exchange. This technique consists of replacing ions present in the structure with others that are in a molten salt solution. Since the new ions have different ion polarizability than the original, the Scout chain is the refractive index. The optical trains are reflect and transmitted light in the ultraviolet and visible regions. The presence of silver ions has the ability to intense optical fields. Therefore, the sample are good candidate for such substrate. The ongoing perspective in the op and laser group is to avaliar useful a capacity in enhanced Raman signal, Rodamin, XD, and the probomolec. Thank you for attention.
Good afternoon. My name is Gabriela Kupelnik Martins, and my supervisor is Francisco Carlos Serbena at the State University of Ponta Cross. My work is about the characterization of class system contain heavy metals and rare earth. My objective studies and characterize the system structural, optical, and mechanical. The class sample shows cubic crystals due to the vitrification and heat treatment led to the formation of a second crystalline phase. The system exhibits high density and volumolar X-ray, confirming the crystalline phase oxide bismuth of the process of oxide. While FTR reveals a transparency window. UV rays analyze artifact of observation and spectral transparency. Finally, mechanical test shows that the system is fragile. Thanks.
So, hello everyone. My name is Giovanna Lira. I'm postdoc research in Virtual Materials Lab at Federal University of São Carlos. My work is chemical straining of transparent glass ceramics, especially analyze the influence of residual glass composition. So, the goal of this work is to investigate the impact of residual glass composition on the mechanical properties of transparent lithium disilicate glass ceramics after the ion exchange process. Oops, sorry. So, as you can see in the second graph, there is a great difference between the microhardness profile in GNA and GNI glass ceramics. So, these changes is related to the slight difference in the residual glass composition of these glass ceramics, which influence the residual stress generated during the ion exchange process, as well as the surface property, like thermal coefficient expansion and indentation resistance. So if you are interested in this topic, I'd like to invite you to see more details in my poster during the poster section. So thank you.
So, hello everyone. I'm Guilherme Ribeiro Capelin, a PhD student at IFSC USP under supervision of Professor Marcos de Oliveira Jr. And the objective of my research is the synthesis of MOF crystal glass composites combining luminescent MOF with ZIF glasses. So, the MOFs are 3D crystalline structures with organic linkers that can form porous glasses, introducing a new category of glasses. One example is the ZIF 622, which has a higher, very high glass forming ability ever reported. And in the first month of my PhD, I have successfully obtained the glass from the system as confirmed by GSC, XRD, and MNR. And the next step of my research is to obtain composites of these glasses and luminescent moths. Thank you.
Hello, my name is Gustavo, and I'm a master's student at the University of São Paulo, here in São Carlos. My project is entitled Exploration of Glass Formation and Single and Mixed Ligand Zeolitic Imidazole Frameworks, the ZIFs, under supervision of Professor Marcos. My objective is to investigate the glass formation of a variety of ZIF compositions and to provide insights into the underlying processes behind through structural studies using solid-state NMR and other techniques. As I have just started my research, I would like to share my proposed work. ZIFs are a subclass of the meta-organic frameworks, a new class of glasses that have recently emerged, offering new processing opportunities. My research explores the crystal-to-glass transition and investigates how linkers affect stability using solid-state NMR. This fundamental knowledge can expand the applications of MOF-based materials. Thank you.
Good afternoon, everyone. My name is Han Meng. I'm the first year of PhD from Shanghai, China. And my work focuses on the effect of alkali metal on the glass structure in mixed former system. And all the experiments from NMR, solid-state nuclear mechanism resonance. And we can see the first picture named CT-DQ Drena is checked to the homonuclear, the dipole reaction of phosphorus. And the second one named Riddle. This experiment is to check the interaction, spatial distriction of phosphorus and aluminum. All the two experiments are all from the wonderful Professor Heimer Aka, best respect to him. And I also calculated the number of aluminum and the chemical bond. Welcome to talk about me. Thank you, everyone.
Hello, there we go. Hello, my name is Jacob Kasprick. I'm a grad student from Alfred University. My main topic is investigation of effects by various ion exchange methods on mixed alkali lime silicate systems. The objective here was to study or investigate how different alkali lime silicate systems can lead to different outcomes from ion exchange processes. 3 cases we considered: a sodium-potassium exchange system for strengthening the glass via a 2-step ion exchange, a potassium-lithium system for viewing the redistribution of sodium ions after a 2-step ion exchange, and then a 3rd system, a lithium-sodium system for how you can actually cause pacification through ion exchange. Oops. Too far. And then these are my 3 main graphs. So the first graph is I have my depth of my exchange from my 2-step ion exchange. That middle graph is about the sodium redistribution in the glass. And then the 3rd final graph there is some XRD about opacifying the glass after ion exchange. And you can always come to my talk and we can go through all these as well. Thank you.
Okay, hi everyone, my name is José. I am a PhD student at the San Carlos Institute of Physics at the University of São Paulo. My advisor is the Professor Euclides Marega Jr., and my research is about the ultrafast emission in plasmonic structure coupled with telluride nanoglass doped with erbium ions. One of interesting results is the enhancement of the erbium emission, erbium luminescent emission, when the erbium is onto the plasmonic structure, and the ultrafast decay of picoseconds, or when the erbium ions is onto the plasmonic nanostructures. In this case, the plasmonic, gold and slits. For my results, I will be present in the poster session. Thanks for your attention.
Hello everyone, my name is Josiah Leary Adams. I'm a PhD candidate from Washington State University. So Washington State University is on the west side. So most times when I tell people, they think it's in DC. I'm not that special. So we're in Washington State, so on the west side. And I'm super happy to be here because a month ago, that's what Washington State looked like. It was a lot of snow, so I'm finally happy to get some of my annual days of vitamin D. So that's super great for my time here. So my work so far, this is just a summary of my PhD so far. So it's developing glass-based nuclear waste forms for legacy and future waste streams. So using glass as some sort of double-edged sword for looking at legacy waste from the Hanford plutonium development and looking at future waste streams from reprocessing of spent nuclear fuel. So for the flash talk, I'm gonna talk just a little bit about the future waste stream. So we designed an aqueous hydroxide slurry, did some thermal processing, some hydrothermal synthesis methods processing, had this iodine-loaded powders, consolidated those with glass binders, and then had this composite waste form, did characterization to make sure that iodine-129, which off-gases when we reprocess that spent waste, doesn't volatilize and get into the environment. So we did use glass as a binding material, looked at microstructure and how that glass interacted with the composite waste form. That crystal structure is the solite phase, which does the job of immobilizing iodine-129. We also did chemical durability, and so we looked into some special glasses that were going to get the job done. So for more information, please come to my poster. One fun fact, I was supposed to be at the glass school last year, but my visa got some issues, and it looks like this is the best example of when the stars align and the school is done the next year, which has never happened. So Ricardo was teasing me today that it looks like Dr. Edgar had me in mind when he did this school the following year. So thank you so much, everyone.
Hello, my name is Carlton. I am a student integration materials engineering, and objective project use machine learning and processing new glass formula is measure coefficient spatial dynamic and cite long and cite wide. Principal result comparison of the distribution of spatial coefficient value after removal of the possible outliers and dilatomeric curve of composition with success and obtain do glass with machine learning.
Hello everyone, my name is Kalis Atou. I'm a first year PhD student currently at Institute of Physics of Rennes in France. My supervisors are Dr. Maxime Vassot, Jean-Pierre Guin and Denis Moreno. My PhD focuses on the nanostructuration of silicate glacis by using different simulation techniques at different scale. We would like to synthesize new glacis using water molecules in them. To do that, we are going to use different simulations like molecular dynamics, some Monte Carlo and phase field approaches. Using this simulation will allow us to study the new phase separation, the new phase state of such glasses and their mechanical and thermal behavior. So here you have a picture of the morphology of silica, of a silica cube containing about 30% of water. And on the right, you have a schematic of the force field I'm currently implementing in my research. So that's it.
Sorry, never mind. Sorry for technical. I'm Krzysztof Gadomski from Warsaw University of Technology, and in my PhD thesis, I'm trying to test the mode theory of conductivity. And let's look at how it works. So when we took glass and heat it up, everything goes exactly as theory shows, but around the temperature of crystallization, conductivity rapidly increase. And what is also interesting that this conductivity at the end, so conductivity of materials which combine with glass and ceramics, is strongly related with this maximal temperature of crystallization. So if you are interested in the subject of conductivity in glass and glass ceramics, please meet me at the poster session. Thank you.
Hello, my name is Lauren Meyer. I'm one of the Alfred students here, and I'm in Collins' group. My project is on statistical mechanical models of alkali/alkaline earth aluminum borosilicate glasses with the goal of predicting viscosity computationally. Our goal is to predict viscosity with a physics-based approach rather than a neural network approach so that we can get our uncertainty from this model. And we are using a bunch of different techniques that already exist in literature, throwing them all together and finding and producing viscosity using molecular dynamics, statistical mechanics, topological constraint theory, and using that to produce our viscosity parameters to get a temperature-dependent viscosity curve. If you have more questions, you can ask me when I'm at my poster. All right.
Hello, my name is Lenora Haight-Stott. I'm a master's student supervised by Dr. Munke at the New York State College of Ceramics at Alfred University. And my master's thesis is focusing on the bismuth-zinc borate system, specifically the pyroborate system where the oxygen to boron ratio is held constant. This predicts that there would only be B3 units present in the structure. However, IR and Raman spectroscopy confirms that this is not the case. And the presence of zinc and bismuth in this system is not a simple mixed modifier effect, but that zinc and bismuth are affecting the borate speciation in very different ways. In the case of zinc, it is causing a disproportionation, and in the case of bismuth, there can be agglomeration of bismuth within the network, forming these bismuth-oxygen-bismuth bonds, or linkages. And I would love to talk to you more about this at my poster. Thank you.
Good afternoon, everyone. My name is Leonardo, and I'm a master student at the Federal University of São Carlos, and my supervisor is the Professor Ana. And today, I will present my work on electric field-assisted process of sodium conduction solid electrolysis. So, the flash sinter is used to get a two-nanosecond system, a ceramic and a glass ceramic, as a possible solid electrolyte with a high ionic conduction. And the flash sinter is used to reduce the processing time and the temperature compared to the conventional sinter. And the first results use the conventional sinter for the ceramic sinter shows a total ionic conduction of 0.7 millisiemens per centimeter. And the next step will test the flash sinter and the dopant test in this system. Thank you.
Hello everyone, my name is Loïc. I'm a fresh PhD student, come from France. And my PhD is a collaboration between the University of Rennes and also the Industrial Saint-Gobain. And the objective of my PhD is to formulate glass-frit to reach thermomechanical properties to allow the enabling process. So that's why I use some classical techniques, such as differential scanning calorimetry and dilatometry, in order to reach like a glass transition, temperature of crystallization, or coefficient of thermal expansion. Thanks.
Hello, my name is Luana Bassetti. I am a dentistry and master's student. And today I go to talk about my research, development of photosensitive dental porcelain suspension for 3D printing by digital light processing. A collaboration between the School of Dentistry at Araraquara and the School of Engineering at São Carlos. In dentistry, 3D printing is used to manufacture models, mouth guards, oral applications, and temporary crowns. But there are only a few all-ceramic crowns for final restorations. We aim to develop a dental porcelain by 3D printing using a simple DLP method. Dental crowns are manufactured using three main methods. The conventional method, a dental technician manually makes the crown layer by layer from a mix of powder and liquid. The subtractive manufacturing uses the CAD-CAM system with a milling, but is expensive and wastes material. And the additive manufacturing also uses the CAD-CAM system, but with a 3D printer, layer by layer of suspension, like the conventional method. That is a new method for our applications, automatic, but needs to be improved. There are preliminary results from the particle size characterization, the viscosity test, and the stability test. The best suspension was chosen for the printing tests. In the next sections, uniaxial pressing specimens will be compared to be printed ones, being evaluated density, elastic modulus, roughness, hardness, X-ray diffraction, SM, and EDS. Thank you for your attention.
Okay, so that is glass ceramics based on bismuth, silicon, aluminum oxide glasses. And what you can see in this transmission electron microscopy image is a crystalline grain embedded in amorphous matrix. What is interesting is that this crystalline grain is made of delta-like bismuth oxide phase, which normally is stable above 730 degrees Celsius. I have few working hypotheses why it is stabilized down to room temperature in glass ceramics, and I think that I would be happy to explain it to you at my poster. So my name is Maciej Nowagiel, and hope to meet you at the poster session. Thank you.
Hello, everyone. Good afternoon. My name is Marcelo. I'm a master's student here in University of São Paulo. And also, I'm a member of Photonics Group. And my advisor is Professor Leonardo De Boni. And today, I'm going to talk of a part of my master's work is the random laser effect on bacterial nanocellulose aerogel coated with silica and titanium oxide. And we use rhodamine 6G as a gain medium. So this work, we can see the laser action on this kind of material is a new material, is entirely organic. So we have the synthesis of this material. So the bacteria create this cellulose, and we did a coating with silica to protect the nanofibers, to protect of the degradation of titanium oxide. And we did the titanium oxide deposition to act as a scattering centers. And after that, we put rhodamine 6G to acting like a gain medium. So we can see that in this graph, two different kind of regimes. The first one is only spontaneous emission. Oh, sorry. Only the spontaneous emission here. And the other is stimulated emission. So here you can see the fluorescence of our material and the laser emission in this regime here. And also we can see a narrowing of the bandwidth. And this material can be used in many applications like image systems, water purification, and random laser creation. If you have more questions, we can talk more in the post-session. Thank you, everyone.
Is Marcio here? No, right?
So, Mateus.
Good evening, everyone. My name is Matheus José. I'm a master's student here at São Carlos Institute of Physics. My advisor is Professor José Schneider, and our work is about the amorphization of lithium and aluminum phosphates through mechanical methods. So in this work, we are using the high-energy mechanical milling implemented by a planetary ball milling as an alternative route for vitrification, like usual melt quench methods. In this work, we are currently studying the amorphization of two crystalline phosphates, lithium calcium and aluminum metaphosphates, and the objective here is to do some structural analysis as a function of the milling time, using like calorimetry, X-ray diffraction, and especially NMR. As an example, I show you here the evolution of the NMR spectras for both crystals as a function of this milling time. We already have some other interesting results, so please feel free to join my poster presentation, and thanks for the talk.
Good afternoon, everyone. My name is Murilo. I am a master's student at this university under supervision of Kleber Renato Mendonça. Here I show my work is focused in predicting the nonlinear refractive index on glasses measured via Z-scan in terms of the glass matrix composition using regression-based machine learning methods. Here on the left, I show you the database histogram of the scintillating samples which I use to train my machine learning models. And on the right, I show the best results for an MLP regressor machine learning model. The key point to achieve such results is basically the use of data augmentation to create synthetic samples. And with that, I train my models to achieve such performance. So if you're interested, you can go up to my poster and you can talk about further details. Thank you, everyone.
Hi everyone, my name is Nathan. I'm a first year PhD student in the photonics group in the São Carlos Institute of Physics under the supervision of Professor Kleber Mendonça. I work with nonlinear spectroscopy of organic and inorganic compounds. In this school, I will present the dispersion of the nonlinear refractive index in tellurite-based glass with this composition. We conduct the nonlinear optical experiment using the open and closed aperture Z-scan technique. Here you have the nonlinear the Z-scan signatures, and here we have the nonlinear refractive index and the two-photon absorption coefficient as a function of the photon energy. As we can see, the samples exhibit a high nonlinear refractive index of about 10 times greater than silica in the infrared. In the visible range, around 600 nanometers, it's increased threefold. The dispersion is related to two-photon absorption through the Kramers-Kronig relation. In this curve, the red curves represent the theoretical fitting based on Sheikh-Bahai model for amorphous semiconductors, showing excellent agreement with experimental data. So that's all. Thank you for your attention.
Good afternoon. My name is Rafael Peric. I am a master's degree student at the State University of Ponta Grossa. My advisor is Francisco Serbena, and this work is entitled Scratch Resistance of Barn Silicate Glass Ceramic. The objective of this study evaluates the crack resistance of barn silicate glass where the crystalline fraction varies from 0 to 70%, with a constant crystal size of 10 micrometers. 3S regimes were identified: microductile, microcrack, and microbrasill. And the microductile regime, they were increased with crystallization, while in the microbrasill regime, they were decreased. The study provides guidelines for optimizing the materials design and application of this glass ceramic. The scratch area tangential force measurements and the measured areas and the maximum depth obtained at fixed position along the scratch were analyzed. The measured scratch areas were evaluated as a function of the crystalline fraction and the load applied at 5 positions along the scratches. More details will be provided on the poster of work shortly. Thank you.
So good afternoon, everyone. I'm Renata, a PhD student here at the University of São Paulo, and I work with nonlinear optics and femtosecond lasers. So in my work, I'm interested to characterize the nonlinear optical properties of materials, such as glasses and semiconductors, and I bring some results to you. So the left graph is a glass material that we measure the nonlinear refraction as a function of the laser repetition rate, so we can discriminate the contributions from electronic, nuclear, or thermal contributions in the nonlinear refractive signal. And on the right, I'm measuring semiconductors and evaluating the effect of the crystalline orientation of the semiconductor in the nonlinear refraction and absorption, so I can characterize these materials and evaluate the potential for application in photonic devices. So thank you all for the attention, and hope to see you in the poster section.
Hi everyone, this is for myself. So I'm Ricardo. I finished my PhD 2 months ago, and I'm from Federal University of São Carlos. Anut is my advisor. I studied structural relaxation. I think all of you saw my slides before because I sent together with the template. So I studied structural relaxation, and what I will show you is my most interesting result that I got during the PhD. In the left graph, you see how the effective temperature changed after relaxation. It changes a lot for this glass. This is a mixer modifier glass. And related to this, all the properties changing. In this case, the ionic conductivity. You see it measured in different temperatures. And it changes almost 1 order of magnitude for the same glass. So before the relaxation is the darker colors. And after the relaxation, the lighter colors, it changes a lot. We can talk about later if you wanna. I will have a poster, and that's it. Thank you.
Hey everyone, I'm River Peo. I'm a PhD student at Alfred University in Dr. Wilkinson's group, and this week I'll be showing off my work on modeling the kinetics of glass during sintering to guide thermal processing during additive manufacturing. So on the left here is an example of my model. If we know some physical parameters of a glass system, we can make this model for any system you can think of. The bottom line indicates when we have densified our glass. The middle line indicates, the middle green line indicates when we have crystallized our glass to observable crystallinity under XRD. And the top red line shows when our glass has deformed enough that we no longer have a part that looks like how we want. So if we print a beautiful statue, we don't want it to fall over and look gross. The purple highlighted region shows where we have suitable sintering parameters. So at that time and temperature, you should get a translucent, densified, non-crystalline glass part. And we've done some testing on additively manufactured glasses using this model. And so we have on the right, you can see one of those samples. There is some opaqueness, but it is translucent. We have confirmed there's no crystallinity with XRD methods, and we have high relative densities compared to the glass system we were looking at. We do have some bubbling issues, but we're trying to iron those out right now. So if anyone would like to talk to me about my poster about sintering glasses or glass crystallization, you can come find me there. Thank you.
Good afternoon. My name is Rony Alisson Silva. My supervisor, Francisco Carlos Herbena. My project is determination their curve for different fractions and crystal size for lithium disilicate glass ceramic. My university is State University Ponta Grossa in Paraná. More informers in section poster. Thank you for attention.
Test. Boa tarde a todos. Hello, everyone. My name is Sara, and I come from Croatia in Europe. You can see it here on the map. And I'm a fourth-year PhD student in chemistry, working at the Laboratory for Functional Materials at the Ruđer Bošković Institute. And you can see my mentor, Dr. Luka Pavić, to the left on this picture. And maybe some of you remember Professor Andrea Moguš Milanković. She's also in the picture. And our group leader now is Ana Šantić. My research focuses on the preparation and comprehensive investigation of structural, thermal, electrical, and catalytic properties of phosphate-based glasses and glass ceramics containing transition metal ions. And when you visit my poster, you will find out that these glasses and glass ceramics can indeed be promising materials as catalysts in epoxidation reactions, as well as potential materials for electrolytes and electrode materials, depending on the type of electrical conductivity they show. So what we found out is actually that by simple changes in the composition, we can greatly improve both catalytic and electrical properties. And specifically, glasses containing higher amounts of vanadium pentoxide exhibit the greatest catalytic activity and selectivity. But also, it is interesting that exactly these glasses with high amount of vanadium pentoxide also show the highest electrical conductivity. But what I will show you too is that by simple changes in the composition, we can actually fine-tune the mechanism of electrical conductivity from purely ionic to mixed ionic polaronic to purely polaronic, just by simple changes in the composition. Thank you.
Hello, my name is Sarah Yvette Laux. I am a first-year PhD student at Alfred University, and I'm also in the Dr. Wilkinson group. And my work specifically is with the glass formation from the oxidation of ceramics with regards to extreme conditions. So what I am looking at specifically is silicon carbide. Silicon carbide will oxidize, and when silicon carbide oxidizes, this forms a glassy surface on top of your silicon carbide. And as a result of this oxidation, this creates a weak point which leads to fracturing. And how I'm approaching this is I'm first using DFT with quantum espresso to go in and understand the energy. From the energy, I can get the bulk modulus through equations of state to better understand the fracture mechanics. Then I can take my information that I've learned, apply it to molecular dynamics, and then from molecular dynamics, apply it to peridynamics to get the best understanding of fracture. And as you can see here, there's a photo of how the glass forms on top of the surface. And the reason why we care so much about this is that this directly applies to hypersonics. And so if we want good hypersonics, we need to really understand what's going on behind this glass structure and how it forms and how do we characterize it. Thank you.
Hello, I'm Pavel. I'm from IPG Photonics Corporation. I'm working with Dr. Leonid Glebov. So we are manufacturing and developing photothermoreflective glass. This is glass for high-power galography elements. The photothermoreflective process for recording the hologram element includes 3 steps. First is irradiation, at which step the silver ions getting an electron. At second stage, it's a heat treatment. The silver atoms are aggregates in nanocrystals, and at the third stage, at the heat treatment, the sodium fluorine is aggregates on the silver nanoparticles. So we melted the new type, the heavy doped by barium glass, and we studied characteristics of this glass. So basically, I was interested in correlation of the viscosity data with the data of silver crystallization. For further information, please visit my poster. Thank you.
A very good evening, everyone. So I am Shweta Rani Keshri, and I'm a final year PhD student in the Department of Material Science and Engineering from Indian Institute of Technology, Delhi, India. So I am doing a PhD under the co-supervision of Professor Anup Krishnan and Professor Nityanand Goswami from IIT Delhi. And I will be giving a poster presentation on the topic ion dynamics of sodium aluminophospho-silicate glasses and the composition structure property correlation. So specifically, my objective is to study the ion dynamics of these as-synthesized glasses, which I will be using as an electrolyte material, and to correlate it with the associated structural changes using various characterization techniques such as Raman spectroscopy, impedance spectroscopy, NB simulations, and also finding the configuration entropy. Okay, yeah. Yes. So as you can see in the first figure, I have used impedance spectroscopy, and I have tried to calculate the ionic conductivity of the glasses. So we can see that instead of a linear trend in the ionic conductivity, we can see that there is a nonlinear trend. And one of the glass compositions is giving a highest ionic conductivity, followed by a further decrease. So in order to know why this is happening, we have performed different characterizations such as Raman spectroscopy as well as MD simulations. And if you want to know the reason of the nonlinearity, please follow my poster. Thank you.
Hello, everyone. Good afternoon. I'm Thalia, and my surname is Souza. I'm graduate of Materials Engineer, and actually I'm PhD student in Material Science and Engineer with the advisor Edgar Zanotto. My works had produced bactericidal glasses of high durability for application in coatings of titanium dental implants, more specific in the abutment, the gateway to bacterial infections. The objective is to prevent and avoid periimplantite, an illness that affects the region around the implant after 6 years of implantation and cause its loss due to poor oral hygiene. Therefore, using glass coatings that contains metal ions that are harmful to bacteria makes it possible to eliminate pathogens directly in the affected area, making it a promising alternative to the systemic route. I wish you a good event. Thank you for your attention.
Good afternoon, everybody. My name is Valdinei. I'm a PhD student here at USP, and I will show you some highlights of my work, okay? Glass composites based on rare earth doped upconversion nanoparticles impregnated in zeolitic imidazolate frameworks. The project is supervised by Professor Marcos and Professor Andrea. The main objective of the project is the development of composites of glassy ZIF62 and incorporate these glasses with upconversion nanoparticles to explore in the future the potential of this new material for photonic sensors and light emitting devices. So, for this, first we need to synthesize the crystal. You can see in the first image an scanning electron microscopy image of the crystal, followed by the NMR spectroscopy confirming the crystal, okay? And studying the thermal behavior of the crystal, we can see the lower temperature of processing of this material. And this is interesting to incorporate nanoparticles in the glassy matrix. So in the last image there, we can see the nanoparticles made of erbium, okay? And I will be waiting all of you in the poster, okay? Thank you very much.
Hello everyone, my name is Vinicius Aloco. I'm a PhD candidate. My supervisor is Ana Cândida. We study ionic conduction in solid state for solid state batteries. And today I'm going to show you one of the works of my PhD, which is the determination of effective charge carrier density in lithium disilicate by impedance spectroscopy. And the main objective is to investigate the individual contribution of charge carrier and mobility to separate this contribution on the overall ionic conductivity. So we did this using complex permittivity on the left. So on the top we have the real part, on the bottom we have the imaginary part. And Using this, we were able to determine the number of effective charge carriers, as you can see on the left side. And as a consequence of determining this, we found out that the increase of ionic conductivity, at least at vac temperature, is mainly due to the change in mobility of these ions. More specifically, 80% of the total ionic activation energy of the conductivity is related to the mobility of these ions. Thank you.
Hello everyone, I'm Yazhou Zhang, a PhD student from Chinese beautiful country, Shanghai. And my supervisor is Professor Zheng Lu and Professor Hu Lili. And I'm interested in gas crystallization by molecular dynamic simulations in several systems, including lithium, aluminum, silicon gas, ceramics, and photothermal refract gases, and others. And I'm going to introduce briefly my work, crystal growth and structure evolution in LS system. And in this work, we successfully simulated the crystal growth in LS system, and for the first time, as we know. And we put the nuclear system and heat treat it for different time periods or different temperature. And the crystal's fraction is analyzed by the bound order parameters, and then finally combine the various theoretical models with the MD results. So the details is shown in the poster, and if you have any question, could contact us with the email. Okay, thank you.
So is there anyone else? Did we finish? Não tem mais.
Anybody else? It's funny because we only had 45 fire talks, and there are more than 45 students registered. Okay, well, we are going to find out. Anyway, this is not compulsory. If you're not willing to give a fire talk, no problem. So what time is it now, please? 3:10. It's too early for coffee. Coffee is... Speed up. Yeah, pendurar o poster, yeah. So yes, so I have good news and bad news. The good news is that I went to a bank to get your per diems, your cash to cover your meals and hotel expenses. Good news is I got money. Bad news is you have to come tomorrow to our lab, LAMAV, to get that money, to collect that money. This is a very good strategy to force you guys to come to the lab. So tomorrow you can collect your money for your hotel expense. So since we have enough time, let's go downstairs, hang your posters, and we start the poster session. I mean, there's no reason to delay that. Let's start so we have longer time for poster. Then we have a coffee break, then you can go to your hotel, take a nap or something, and 5 p.m. we take the bus, okay? So thank you very much for all your talks. I think we now have a nice idea on who is who, more or less a nice idea. I'm an old man, I'm not going to memorize everything, but I will memorize some. Just for statistics here, who is from Poland? Please raise your hand. 4 from Poland. Yes, thank you very much. Croatia? Yes. send my regards to Andrea. You know, she was a professor here, you know, in this institute. Yeah, for many years. For many years, yes. So send big regards. From China, who is from China? 2, 3, and yes, 3 people from China. From USA, 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 USA. Well, thank you, thank you. Canada, yeah. France, 3 from France, thank you. We had another student, but which became ill in the last minute. He got a COVID in the last minute. So the 4 students not coming. Any other? Huh? Nigeria, yes. Well done, well done. Thank you very much. Well done. Russia, yes, Pavel. Thank you very much for coming. I have to talk to you because we have a very pure quartz powder that will be perfect to produce your photothermal refractive glass. I'll show you tomorrow. Yeah. Any other? India, Shweta, India. With our best regards to Professor Lily Hu. Professor Lily Hu, her supervisor, is one of the top women glass researchers in the planet. I think she is one of the most prolific. But with Lily, you said? No? Oh, no, Lily. No, you were Lily. No. This guy, your supervisor is Professor Lily Hu, right? You, yeah. Professor Lily Hu. Your supervisor is Anup Krishnan, top guy in machine learning. Anup is a young guy who is producing a lot of papers. He is very good, very, very good. So, see, we have people here from the very best supervisors in the planet here. And any other country? Colombia. Oh, very good. Thank you for coming. Very good. Colombia. Pakistan. Okay. Very, very good. Very good. Is there anybody from Brazil here? Okay, a few Brazilians. Thank you. Yes, Brazilians. Okay. Anyway, I'm telling this because this is a real international meeting, and the whole thing is, you know, keep this WhatsApp group that will be useful for you. I was telling to our friends last night that I still keep in touch with the students from the first school. The first school here in 2015, there are like Azat Tipev, Duygu from Turkey. There's somebody from Turkey. Sorry, Turkey. My good friend Duygu, she came here in 2015 for the school. She is a well-known researcher now at CICEJAM. Anurag Gadan is a professor in Portugal. So we had Will Lepre. We had several people here in the first school who became professors or researchers. They're doing very well. And I keep in touch with them. I meet them in conferences. We exchange emails, exchange papers. That's the idea. That's the idea. So you are starting your own network and keep that. Anyway, let's go downstairs for the posters, and later on we have a coffee break downstairs. Eu acho que você pode ir por aí. Yes, yes. Yes.
You mentioned earlier that part of this meeting is for collaboration and networking. So I'm suggesting that the student should drop their LinkedIn ID in the WhatsApp group so that we can both connect with each other and build the community. Yeah.
You have already the WhatsApp group. So we have almost everybody is there, almost everybody. You have the telephone numbers, etc., etc. But yes, very good. Any other suggestion before we move downstairs? Okay, let's go downstairs then. for the posters.